how the difficulties while doing the survey in the field, and what are the the major application of civil engineering, especially in the survey point of view. And there are many organizations which they were hiring the what you call the civil engineers as a part of surveyor, as a part of resource water resource engineer, as a part of what you call the geotechnical, concrete technology, or structural engineers. But when it comes to the survey part, it is I mean I would say it is integrated with the remote sensing and the survey part of India, right? So let's those things we discussed in the yesterday's class. Okay, so today we will discuss about the the first part of the I will discuss about the uh, units of measurement and compass survey, classification of survey, and all those things. We can start the survey now. Okay. In classification of survey, and we are doing the the compass survey, tape survey, chain survey. I think yeah, I think we have basic survey, right? And, okay. I think in the yesterday, yeah, chain survey and compass survey, plane table survey, and also in the drone survey, right? And also for the total session, and even for the what you call dumpy level, auto level. Okay, there are different types of instruments which use it for different types of task. Okay. Why I'm telling you in the repeating session, repeating stages, because you are not familiar with the, all these instruments. Okay, do you agree with me? Do you agree? So, Adarsh,
Yes, sir.
Adikeshav,
Yes,
yes,
sir.
you are not familiar with
Yes,
the,
sir.
in the first year you studied what is elements of civil engineering, basic of all the common subjects, right?
Yes, sir.
So you entered into the civil engineering department just now, right? So you need to familiar with most of the instruments and measurements in the survey types of surveys and all, right? So here, what I would suggest, yes, classification of survey we discussed, and the definitions, and general principles of the surveys, and also the what are the technical terms and used especially in the surveys, what are the main stations, what are the main survey lines, baselines, and tie lines, subsidiary lines, that means, and check lines for the checking purpose, whether it is correct or not correct. Those things we need to use in a survey part. Okay. Benchmark is the most important, especially in the survey, and that generally it will not disturb from anyone. Intentionally, if they disturb, that is the not in our hand. But generally, it will be there for many years. Okay, that is the boundary for what you call this for many land. The properties or whatever the things. As if you take the survey of your agricultural land, there will be a benchmark from where they are going to start the survey. That's called their initial reading. Uh, could you please tell me where you will get the RL elevation? Say, for example, if you want to take the survey by the the theodolite or from the total stations. Just some general questions I'm asking you. From where you are going to get the RL? From the ground. So not in the paper. Okay, it's difficult to locate from the paper to the land. In paper, in paper, it may be there in the exact location, but it may not be there in the land. It may not be there in the exact area where it is in the land. Okay, how you are going to start? How you are going to carry the RL? With a known RL, you need to start. Where you are going to get the RL, first RL? Any idea? Maybe you have seen that. Maybe you have seen that, but you may not, know that yes, we are going to use this RL for survey purpose, or it may be any other purpose. Have been travel in the train? Maybe most of the people have traveling in the train. Yes or no? Chiranjeevi, Dipti, Dhananjay Kumar?
Yes, we have traveled.
Yeah, have you traveled? Right. Have you been there any numbering in the railway station? In the railway station, have you seen in the board, there may be some numbers?
Near the tracks.
Near the tech, what number it would be? Do you remember that?
No, sir.
Okay. Anybody? Dhananjay Kumar? Dhananjay? Yes? Divyasri? You have seen that. I know you have seen that, but you'll ignore that. Okay, some number maybe the railway department, some code must be there. That's why you just to see that and you just forget that. I think. Huh?
It's a height from the sea level.
Yeah. That's right. That is actually though the MSL. They written the MSL. Units is in the MSL. That's called mean sea level. From the sea, that much of height. Say for example, Bangalore railway station that is located in the what you call in the central city, Majestics. And maybe they have written the in one corner, not in every pillar it is there. Somewhere it is in the corner of the railway station. It is written very clearly with a bold with a big letter RL. Or generally they are not writing as an RL, MSL, mean sea level. With respect to the mean sea level, the Bangalore railway station height will be this much, maybe a 500, maybe a 1000 meter or 975 meter RL. That's all. That means with respect to the mean sea level, this is a 975 meter height. So wherever you are going for survey, you need to search for the nearest railway stations or known the benchmark which is there in the Pani or it is maybe in our survey department. From there you are going to start the survey. That is a known RL. From there your land may be the 100 meter or maybe a 200 meter. You need to take a traverse from the known point to the where you are going to survey the. From there you need to traverse. Take a traverse. Initial reading is your known reading, and then you can continue with the survey. This is how the things. And for if you have the GPS, no need to do the survey. Sorry, no need to go for a known RL. Okay, that will GPS. It will give you the exact location where you are locating. If you are standing in the BMSIT college, it will give the BMSIT college latitude, longitude, and also the RL that called MSL. In survey point of view or in civil engineering point of view, we call it as a RL. But when it comes to the general topo sheet preparing survey of India, or it may be in a railway station or general common people, even if you take whatever GPS, it's showing the MSL, mean sea level. Okay, that's how the things. So with the GPS, you can start from anywhere in the world because it is already set, inbuilt. Data is inbuilt is there. Wherever you go, it carries your the location, the path, the traveling points. Okay. So like that, but if you want to take total station or theodolite some other things, you need to look at the nearest RL, the benchmark, or it may be in the railway station. From there, you need to carry out the things. You cannot measure by tape or some other things. Okay, that's the thing. When you are using the GPS, that's the best one, but the accuracy may be the 3 to 4 meter error will be there for that always. Okay. That's the thing for that we discussed yesterday, right? And this plane table survey and geodetic survey we discussed there, and the chain survey that's we are discussing in the studies. So now let's go with the what you call this Compost survey. most of the people have seen the compass, maybe in the internet or maybe physically. You may not be seen because you're not done any such type of work because even GPS also you can see in the mobile itself. Even compass also, normal compass you can see that. It may not have the graduated the 360-degree angle. The circle may not be there, but you have the compass in your mobile. Okay, it may show. It will show definitely the northeast, southwest directions. Okay, and this is a survey. What you call this compass survey. Okay, generally used to take in the earlier days. Still, we are taking for bearing, taking the bearing and angle. And also we used to take this compass for for the measurement of angle of inclination of the bedding planes. The inclination of the bedding planes of the any rock formations. Okay, we used to take the things. Here there is a oh, okay, here there is a typical mirror will be there. There is in between there is a one line, and here you can see this. This is a line here, and this is a graduated circle there, and this is 0 to 360-degree angle, and this is a north-south directions. Always the red mark indicates the north direction and the south directions. Okay, and this is the thing says. When you look at the the what you call the direction, you have to see from the here, and it has to pass through this. Okay, then only you can see the clear directions of that, and then you can take the reading of any of this, whatever the reading it is coming in there. Maybe that's in the whole circle bearing, or it may take the quadrangle. Okay, whole circle bearing is the 0 to 360-degree. Okay, quadrangle means 0 to 90, 90 to 180, 180 to 270, 270 to 360-degree. Okay, that's a 4 quadrantal angles. Okay. So this is the same one, and but some the olden compass, prismatic compass, you can take out this, and you can focus the target from this what you call this mirror, and you can align that properly. Then you can take the reading of the whole circle bearing. Okay, this is just for alignment. Rest of the things you are doing in the plane table survey, it is for just for the alignment. Okay, for water pipelines or for your any road construction, tunnel constructions, it is just right. This is a basic survey. What is there in the prismatic compass? That's the most important. That is a complete box. The first one where it is there here, this compass setup, and there is a needle as I shown it here. There's a needle here. This is a needle, complete needle. And this is a graduated ring that I told you in the 0 to 360-degree. That's a graduated ring. And object van is also there. And I van, as I told you that I van is here. Okay. And prisms will be there. And prism cap and glass covers, lifting pin, and lifting lever, and now brain pin and spring brakes. And there are some mirror, pivot, nugget, focusing stud, and sunglasses. These are the main parts of the prismatic compass. Generally, we use this for in the border for navigating and also directions. Generally, in the latest technology, we use this compass for alignment as a civil engineer. But in the border, in defense, since beginning many years back, only they started this with the compass. They have the very good degree, the degree minute seconds. I would say it's a degree minute seconds.
Sir?
They have the
Excuse me,
things.
sir. Sir,
Yes, Harshita.
I can't see the screen, sir.
Screen off.
We can't see the screen you're sharing, sir. We're just listening, that's all.
Ooh, it's too much time. I forgot to share the screen. Nobody is telling that.
Sir, I thought only I was not able to see, but others also are not seeing.
Okay, right. Thank you, Harshita. Eh? Oh. Okay, right. Yes. Can you see now screens?
Yes, sir.
Yes, sir.
Okay. Right. Sorry. That's my mistake. I think. Okay. Sorry for that. And yeah. Uh, okay. This is, the Compost survey generally used to carry out for all the things. The survey for, for water pipeline, for any alignment, road, railway track, or even for a tunnel also. Okay. Generally used to this compass for nowadays GPS has also come. Okay. Before that, we use this compass for the navigation purpose in the BSF defense areas. Okay, because their maps are completely, angle, distance, and angle. Only two there, and there are surface features. You need to follow that one only. That's how they have the. Still, they are not using maybe the GPS because if there is no signal, no, you will lost the location and you will lost yourself in the areas. If you have the compass or if you have the very good map, location map, definitely you can survive in the unknown areas, not in the known areas. Okay. Generally, we used to take out this compass for mineral explorations. Okay, to find out the not a distance actually, find out the directions and angles. Okay, and sometimes in the by evening, if it is in the thick forest, it's a too dark, and it's very difficult to get thick forest. This what you call GPS. GPS signals. It's very difficult to get it in the thick forest. So compass is the best one to get the direction. Okay, and also the degrees. So easily you can reach your the camp without any issues. Okay, this is how the graduated circle inside that. And here is the what I showed. This is a needle, and this is a graduated circle, 0 to 360 degrees. You can read it as a whole circle bearing, that is a WCB, called whole circle bearing, or you can read it as a different quadrangle. Say for example, 0 to 90 degrees the first quadrant, 90 to 180 is second, 180 to 270, and 272 to 360. Like that also you can read it. That is not an issue. While writing the degrees, you need to mention clearly. That's all. Okay, that's how the things. And third thing is that there is a the mirror with a line of this here for that alignment purpose, so that your the bubbling center should be the center. Can you see this bubble here inside? This should be the proper in the at the center. Okay, this is how you need to set your plane table setup also. Okay, for that also it's very useful. Okay, and this is called a prismatic compass. And for the prismatic compass, and here, yeah, prismatic compass. This is the typical parts of the prismatic compass. Okay, there are needle, graduated ring, object van, prism, and this lever. Okay, and there is a spring and the mirror will be there, and this is a typical part. So let's go to the next slide now. Okay. And here you can see the prismatic compass parts in that. So this is an mirror adjustable, and it's called objective van here. On top of that, the horseshoes and glass, and this is graduated circles, and here it's a focusing. This is called focusing the sunglass and eye slips and eye hole, and lifting van will be there, lifting lever will be there. This is the typical parts. Okay, and this is surveyor compass. These are two subs, same one. Okay, what is the difference between prismatic and surveyor compass? And it is actually prismatic compass. It's having the graduated circle is fixed to the broad circle, but whereas in a surveyor compass, the compass, it's gradually fixed to box, and hence it is rotates with a line of sight. Okay, northeast, southwest, and east-west direction. The prismatic giving is the gridding pattern, weaving in the end, and there is no prism here, and there is only a slit. And here in the sighting and reading can be done simultaneously, but here in the sighting and viewing cannot be done in the simultaneously. There are a major difference and graduations or whole circle bearing here in prismatic compass, and here, as I told you, that quadrangle. Four quadrangles 0 to 90, 90 to 180, 180 to 270, 270 to 360 degree angle. You can read that. Okay, and these are marked with the inverted since it is reflection in the read through the prisms. Okay, and here it's marked directly. There is no inverted this ones, and tripod may or may not be used. It can be held in the handheld also. And for surveyor compass, tripod is necessary for this. And yeah, reference direction with respect to the tongles or measured. This is not for this. Okay, and maybe you all know that, maybe aware of this north pole of the directions, and this is called a true meridian, and this is called a magnetic meridians. That's called, this is a true north, this is a magnetic north. Okay, there will be, from side to side, from place to place, this may be a vary, maybe a 10 degree or maybe a 12 degree or maybe a 5 degrees. Depends on the equator, depends on the, the location where you are exactly. Okay, so this is exactly the true north and this is a magnetic north. Generally, we use this terminology for when you are doing for the geological mapping, not for other mapping, not for other survey. Other survey, generally we use it for, okay, where is the north? Okay, this is the north, mark it, that's all. They don't want any magnetic north. Where there is a magnetic north is mostly differ for the magnetic content areas, where there is a magnetic minerals or content there. When you are going to do the magnetic survey, that's called your magnetic, highly magnetic areas, magnetite deposit areas, there you can differ more and more there. Okay, this is true north and this is a magnetic north. That's how it says. Okay, true meridian line passing through the geographical north pole and its geographical south pole, north south. This is completely the north south. Okay, and when there is a magnetic, so when the magnetic needle is suspended freely and balanced properly, and it's unaffected by the magnetic substances, that indicates the directions. Okay, and also the direction is known as a magnetic meridians. Okay, and the angle between the magnetic and the line of known magnetic bearing is called the bearing lines. Okay, that's called a true bearing lines here. It's the dotted angle of this true bearing lines. Okay, and here it's a magnetic. I told you this is a magnetic meridian. Okay, arbitrary meridian and convenient direction as it's a meridian. Full circle bearing. Yeah, how you are going to read the the compass? As I told you that WCB, that's called a whole circle bearing. So when you draw a line, when you did any mapping, I mean the survey, I've done the survey, the magnetic bearing of line is measured from the clockwise, especially from the North Pole. See, most of the maps are not most of the maps. All the maps are with reference to the north directions, north of so and so degrees, towards east or west, or south of so and so east, south of so and so west. Or there is another terminology called northeast southwest, north 10 degree east, south 10 degree west. You agree with this? Can we do the annotation here? I don't think so. Here we can do some annotations. Okay, let me check with the things. Okay, so here, yeah. So whole circle bearing. Okay, the whole circle bearing of line is measured from clockwise, from North Pole. towards the line is known as WCB. That's called a 0 to 360 degree angle. Whole circle bearing, if you are considering, so when you measured any line, towards which direction, that's most important. That's why we use this compass for that. 0 to 90 degree, that's the first quadrant. That means north 45 degree east. If you write like this, automatically the south 45 degree west, that line itself. This is how this is your north, and you are coming here, okay? And I would say this is a north pole, north 45 degree east and south 45 degree west. That's all. Or you can say that north 45 degree. If you say north 45 degree, this means this is from here only. North 45 degree here. Okay. So automatically it will be a south 45 degree. This is a direction. This is a straight line, main straight line of this. Okay. And if you are reading with, okay, north 10 degree east, south 10 degree west, that's the one thing. Or north 50 degree. Anything you can read it, but when you are writing that, you write it properly. That's what. Okay. Right. This is a whole circle bearing towards 0 to 360 degrees. It may be vary that. Okay. And measured with a compass and other things. Right. It's also called as a azimuthal bearing. Okay. That's called a bearing. We call it as a bearing. It's a directions. Okay. That is a one. Okay. This is another one called a quadrantal. Okay. That's called a QB. We call it. Or it's called a reduced bearing. The magnetic bearing of line measured clockwise or anti-clockwise from north, okay, whichever is near to the line, north point or south pole or north pole, okay, whichever is near to that, towards the east or west. As I told you that northeast, southwest, northwest, southeast. So if your line is here, this is a line, and northeast, it will be southwest. If it is a northwest here, and it will be automatically southeast. That's called a quadrantal bearing. Okay, that's a very simple one. You can understand this, and generally measured by the survey compass. Okay. Yeah. Here you can get the clear picture of this. This system is consists of 4 quadrants: north, east, south, west, northwest, southeast. That's all. The values will be the 1, 2, 3, 4 quadrangle, alpha, beta, and gamma. It's a very simple. Okay. It's a reduced bearing, northwest and southeast. Here is the northeast, southeast, southwest. This is called a reduced or quadrangle bearing. Anything you can do it in a systematic way, but while you are writing, you write it properly. Right on. Either you can write this in the quadrantal, or it may be writing in the whole circle bearing of the project. Okay, that is the thing. Right. So the next part is that. Okay. Oh, right. You can do this also. This is a whole circle bearing. What do you have this? And in that, you can 0 to 90, and again here, it's 0 to 90. Yeah, northeast, southeast, southwest, northwest. You can read this type of 0, 30, 60, 90, 30, 60, 90, because every 90 degree we have divided this. That's why we call it a quadrangle. Okay, and this is how the following table should be remembered for conversion of whole circle bearing to reduced bearing. Okay, 0 to 90 degree whole circle bearing, that's the northeast, where it is located exactly. When you give this 0 to 90 degree means that should be in the northeast quadrant. Reduced bearing, that's a WCB. Okay, 90 to 180, that should be in the whole circle bearing 180. That's all. Okay, that should be in the southeast. Okay, like that, 180 to 270, that's the thing. Right. And here, WCB, and it's 180 to it's a southeast, southwest. It's a third quadrangle, and it's a fourth quadrangle. Okay, that's a 272 to 360 degree. So these are all the water anchor bearings, right? Same thing, it's in the reverse way. Okay. Okay. Yes. Okay. When you are doing this, for bearing and back bear taking, that's we are going to take it in the next class. Before that, I would like to show you some of the survey part of this. Your this, the aerial survey for the. Yes. This is, the concept is clear. Gopi Reddy, Divyasri, Harshavardhan. Is it? The concept is clear for this and this? Okay. Okay. So let me show you some of the, the survey part of your this ones so that you can aerial survey, how we can do that. Not for this and slightly aerial survey for this and called videos of this for this thing to take it to the photos videos. Okay, let me take you to the okay. That's not going to happen here. No. The production site. Good producing and yeah. Let me show you some of the videos how the the survey is going to carry out for this. Right. DVD. No more photos now. Let me explain this. What we are going to show you this is a aerial survey. This is what we call it as a aerial survey. Yesterday we discussed about this. This is a aerial survey. What we are going to capture the image of the mines, working mines from the aeroplane. Okay, from the small chopper, we are going to capture the aerial view of the working mines. Okay, and the same things you can capture from the drone. Okay, and but here the thing is just we are viewing the things from the aerial view, but if but of course we don't have the GPS. Just we are capturing the photos and collecting the photos. Of course, you can do the registration with a known latitude longitude. Okay, if you know the RL of this corner of this site from the Google Earth map, you can get it and you can register it and you can do the mapping part of this. How much area is working mines, how much area is the rest of the things. That we can do it. That's not a problem. That will come to the later stage. That's too early to say that if I feed most of the things in a remote sensing, GIS, aerial survey, everything, it will be a too burden for you. Okay, I will give the step by step the information so that you can easily digest the things. Otherwise, it's difficult to. Okay, that I understand that. Just to have a look at this. This is just what we are going to doing the aerial survey for working mines. Okay, so let me show you this. This is actually, it's artisanal gold mines. That means the local people, they are working for the gold. Okay, they're extracting the gold from the surface. That's I told you in the morning. I showed some of the videos there. This is called a secondary gold deposits. It's in the shallow depth, and here it is associated with the laterite and some other soil there, and they're working for the gold projects. And this type of sea, of course, this video is not from the India. It is from the Central Africa. Okay, this is from I would say it's DRC. It's called Democratic Republic of Congo, Central Africa, where the artisanal mining activities happening there. And this type of the mines can happening for the gold and even for diamond, tin, tantalum, almost all the minerals can happen. Same thing you can see this in India, especially from what you call from the Madhya Pradesh. There we call it as there is a location called Panna districts. Maybe you have heard this Panna districts. There is a called diamond deposits. Diamond. Every day the local people are they go for their allotted land, particular the what you call site they are allotted for that 50 meter by 50 meter, whatever the things based on the requirement. The government has allotted for them, local people, and they can every day they can go their particular the allotted areas. They can start digging the materials, and they may get the gold, sorry, the diamond. They may not get. Sometimes if they get small quantity, maybe 2-3 months, they may not get even small quantity, 1 or 2 diamond piece also. Okay, that's a very difficult part, but the artisanal working still happening even in India also, and even in rest of the world also, because the local people they want their land to do the bread and butter for the life for that. Definitely, I would recollect in the last year in Panna district only, there is a very good diamond, the best, the world best, the one single piece of diamond they got it. Maybe you have seen in the television, or it may be in the paper. I have heard this, I have seen, I have read that. Of course, I don't have that proof of the copy of that, but there is a very good, diamond. The one farmer, he got it, and he's so, I mean, he give it to the government or somewhere else, but it's more than 1 crore rupees valuable. One piece of diamond. It's a very well crystallized, and it's a perfect, cutting and polishing that one. That is called the best one, diamond in that case. Let's move that. This is called artisanal mining. That means local people are digging the mine. This is their village, and this is the place where they are working for the gold deposits. Okay, this is aerial view, aerial surveys. That's what we are doing for mineral explorations. You may do for this aerial survey for your locating the layout plan, or for your construction of dam also, so that take the aerial survey for the catchment areas, how far it is, how it can be. Okay, take the GPS, sit in the aeroplane, and take a traverse in the aerial view, so that you can take a one polygon, big polygon. Start from the one point and cover the catchment areas, and you come back to the where you started, and you will get the closed polygons. That's all. So that you will get a complete area of that particular catchment. Catchment is nothing sense. So that is a what you call the basin, one basin. Just say, for example, here you are going to construct a dam. No, this point is not exactly. This is where you are going to construct a dam. You start the survey for this aerial survey by taking this GPS and just traverse in the aerial view, and you can move around this here. Okay, and you can stop somewhere here where you started. This is where you are going to construct a dam. You can take survey. This is the complete the basin, the first order, second order streams. Okay, small river, then making the, joining first order, second order, third order, you can join it in the big, and this is the location. Even a single 1 hour, you can do the survey of this. This may be the more than 30 kilometer of the radius here. It may be, okay? Easily you can do the survey, but it's an expensive one, that I would say. Okay, this is what we did for gold explorations. Okay. Yeah, this is a camp. This is a camp for geologists, and this is a village, right? Right. So this is a one type of one, and what I would suggest you that, oh, short videos. This means too short, and also generally when you take the aerial survey, that is expensive for us. You have to everywhere there will not be any what you call this. Airport will not be there everywhere. That's difficult to get it. Okay, even small chopper 5 to 6 seaters, it's difficult to land it. Okay, for that purpose, what we'll do now? So we have to take the drone survey. Okay, we have to take the drone survey. Wherever you want, you can fly it, and take a aerial view of from there, and you can take the imageries. That's the best one. So expense, cost wise, it's a cheaper, and also it's a movable. Wherever you want, we can take it. Okay, but it's aerial survey, especially in the aeroplane, it's very difficult. Okay. Okay. That's all. What I would say is, okay. This is generally the, in other countries, what they are doing this aerial survey for is so frequently, it's better. Okay, and it's not so too much of expensive for them. No. I need, wait. Yeah, here it comes. So this, yeah. Oh, sorry. It's not going up. Yes. But is again they shown it. This is how morning I show in the mining how it is happening there, and I wanted to show you the how the aerial showed they are going to take it. Where is this? Wow. Yeah. This actually generally it may be a height maybe a 1 kilometer, and surrounding that it may be taking wow, wait, does it disappear? No. Wait. Oh, yes. Yeah. That's maybe a 1 kilometer height, and it may be, around 3 to 4 kilometer, tilting the cameras, you can easily capture the very good image of that. Okay. This is all about the aerial survey and the compass surveys, what we did. This is because I used to work for the mineral exploration and mining companies. We used to take the, drone survey for this, okay? And this is all about the today's sessions. And in the next class, we will meet for the EVS, environmental studies, and we'll finish the today's the classes. Okay. So, do you have any doubts on this? Which one is the best survey for? Okay, for your layout plan, ground-based survey, or the aerial survey? Quick question. Small quiz. Which one is the best
Ground,
one?
sir.
Ground survey.
Yes, sir.
If you have the very big layout, like 10 kilometer by 10 kilometer, or it may be a 5 kilometer by 5 kilometer.
Then
I
aerial.
want quick data. I want very
Aerial,
very quick
Aerial,
data.
sir.
Aerial survey.
Aerial, sir.
How you are going to
Yes,
by
sir.
aeroplane, or by chopper, or by helicopter,
Drone.
or by drone?
Drone.
Yeah. Why do you want a drone?
Sir, because we can easily land and
Easily land and easily take up. Landing and take up is very easily wherever you want. Just you can move it. No
yes, sir.
need of permission of DGMS, I think, for certain heights. If it is your survey area is near to the what you call our airport, then only you may take care of, or you may take DGMS, or from the Airport Authority of India. Otherwise, if you are very far, I think in India you have to take everywhere, but depends on the height where we are going to do that. That's it. Drone survey is the best one. You can set up the GPS and you will get everything there. It's not expensive too much. Okay, that's a quick question for today's sessions, and let's go for the next session in the 3:35. Okay, do you have any doubts on the sessions? And if you have any doubts, you can ask me in the 3:35 session. Okay, thank you very much, sir. Thank you. Harshita, Hitesh Gowda, Kushal, is it clear? Deepti? Hello?
Yes, sir.
Yeah, is it clear? Okay, okay. I'm just randomly calling the name. Okay, that's not an issue.
Okay.
Okay, right then. Thank you very much, sir. Thank you. You can join for the next sessions. 2:40, those who are
Thank you.
going to join. Okay. Thank you. Thank you very much.